Hello all, welcome to the Solocast of Firecode Tech. In these episodes, it's just going to be me, your host, Gus Gagliardi. There's going to be a range of topics, but I'm going to talk about specific technologies, installation standards, codes and how they work, as well as some other interesting topics that don't neatly fit inside of the context of a normal interview. Hello all, welcome to episode 9 of the Solocast of Firecode Tech. On this episode, we have fire pumps. So I wanted to talk about fire pumps. Like I said last week, I really wanted to dive into fire pumps last week, but I realized that I needed to establish first why you would need a fire pump. In this episode, I want to dive deeper into the ins and outs of fire pumps and why you would need them and the codes and standards surrounding the issue as always. And so I hope you will enjoy this episode. If you would like to hear more from me about Solocast topics and some extra bonus interview episodes eventually, you can check out this topic and more at patreon.com/firecodetech. Please don't forget to follow us on social media and subscribe so you never miss an episode. A fire pump is a part of a fire sprinkler system's water supply. In fact, the only reason why you would need a fire pump is if you do not have a sufficient water supply for the design demand of the sprinkler system in which you're trying to install. The only reason in which you would need a fire pump is if you have a deficient water supply, e.g. a city water supply that cannot sustain the design, pressure, and flow needed by your sprinkler system. And so what does this mean to a professional who's in the fire and life safety field? If there is a fire pump present in a facility, this means that in order to supply the required flow and pressure needed in the design area for the sprinkler system, you need to have this pump to deliver that water. And so we talked about in the last episode about how we need the calculation methods to determine the pressure and flow required for the sprinkler system. And so when we've plotted our water supply curve and we take a look at our design demand, and our design demand exceeds what our water supply can give us in terms of pressure and flow, then we have established a situation in which we need a fire pump. Maybe I just said the same thing 4 different times. I'm not too sure. But that's what a fire pump is. A fire pump is a piece of equipment that supplies flow and pressure in order to facilitate a sprinkler system to do its job. In the simplest terms I can think of. I can't find a good definition in NFPA 20 that says, quote unquote, what a fire pump is. It's composed of an engine, a driver, a controller, and so there's a couple different power sources you could use for a fire pump. There are electric fire pumps, and there are diesel fire pumps, and there are also steam-driven fire pumps. I've never seen these before. Apparently they exist. Why you would need to know this is one of the first tasks that you need to concern yourself with when you've realized that your facility needs a fire pump in preliminary design after some of the hydraulic calculations we talked about in our previous episode is that you need to establish if the facility has reliable power or not. And so what is reliable power? So first, before we get into reliable power, let's talk about the controller a little bit more and what that is. A fire pump controller is defined as a group of devices that serve to govern, in some predetermined manner, the starting and stopping of a fire pump driver and to monitor the signal and status and condition of the fire pump unit. And so think of this as the brains of the fire pump. There are a number of different ways you can start a fire pump, and the reason why you might want to consider the way you start a fire pump is if you have... I've not heard of facilities that don't use a soft start fire pump, but if you have a fire pump that doesn't have a gradual start, you can have water hammer in your fire sprinkler system, which can be mechanically damaging to your fire sprinkler system. And so why it's important to know when you need a fire pump or not is that there are sweeping implications for the fire and life safety design. and for corresponding disciplines involved that are impacted. So I'm working on a project right now. We have a preliminary flow test, and we're in early stages of design, and we need to know if we need to program in a fire pump space. So you need to either have a fire rated separation around this room, and the room needs to be dedicated to the fire pump functions. You can't have miscellaneous mechanical, plumbing, and electrical equipment in your fire pump room. It needs to be a dedicated space. And you can imagine that this is not something that a building owner is thinking about when they're thinking of developing a nice brand new facility. Is a, whatever it is, 200 square foot room dedicated to only fire and life safety features. It can be a real bummer for them. So depending on the reliability of your powers, how do you determine if you need a diesel-driven fire pump, an electric-driven fire pump with backup emergency power, or if you can just have your fire pump driven off of electricity with no backup because it's deemed reliable? And you have to be careful with this because some jurisdictions don't recognize this caveat for a reliable power source to exclude a secondary means of power for your fire pump. Depending on the demand for your facility, you might be in a situation in which you need to provide fire pumps in series or in parallel. If you're looking at an aircraft hangar, it's a common occurrence for you to need to provide fire pumps in parallel in order to provide the flow that is needed. And so here's an interesting topic when I discovered this was kind of like an aha or mind exploded moment. Pumps in series add the additional pressure. And so if I have one pump with 100 psi rated at 100 psi and another pump rated 100 psi in series, then these two pressures would be additive, and the second pump would discharge about 200 psi at 100% capacity. And so if you take a look at those same two pumps, say they're rated at 1500 GPM, they wouldn't produce any more flow in series than 1500 GPM. So to put that into context, the volume of water that they could move forward in series, it can be no greater than 1500 GPM at rated capacity, 200 PSI and 1500 GPM. In parallel, it has the inverse effect. The flow is additive, but the pressure is not. And so if you have two 1500 GPM fire pumps rated at 100 PSI in parallel, the flow available at the combined discharge header would be approximately 3,000 gallons, but it would still be available at 100 PSI. And so when I first figured this out, it was kind of like a mind-blowing situation that I didn't understand. And so I've very frequently seen, due to the nature of my company's area of expertise and work, fire pumps in parallel. The extraordinary amount of flow needed to provide a high expansion foam system for an aircraft hangar provides that scenario in which you would need such excessive amounts of water. I say excessive, but really I mean to great degree or severity, like a large just volume of water. There's no other occupancy that I've ever encountered that can come close. A situation in which you might find that you need pumps in parallel would be if you have a campus fire line that is provided with supply by a fire pump. However, you don't want to make your underground fire main all rated for high pressure piping and high pressure fittings, and so you provide not only a fire pump for your campus fire main, but also inside of your building in order to get the pressure that you need for the facility. This might be a situation in which you might need series fire pumps. So they're not in the same building directly in series, but they are as a fire protection system in series. You can need a fire pump but not need a fire protection water storage tank. A fire protection water storage tank is needed when You can't get enough water with your fire pump without cavitating the line. So let's talk about how to select a fire pump. So the first step in selecting a fire pump is performing a hydraulic calculation. After you've determined the need of your fire sprinkler system, or any system really, your high expansion foam system, your standpipe system, after you've determined the pressure and flow needed of your system, and you have acquired the water supply capacity from a flow test, most likely performed in accordance with 291, and you take a look at the delta between the water supply capacity and the fire protection system demand, and then so you need to make up this deficit. And so the fire pump is how you make up this deficit between what the water supply, municipal or otherwise, can provide and what your system needs. And so you want to take the difference between these two lines, these two water supply lines. The way I learned it and the way that I'm comfortable with doing this in my professional career is making a diagram of the water supply capacity, the city water supply, and the fire protection system demand, and charting these out. For the water supply curve, you would put the static pressure observed on the flow test, the residual pressure observed on the flow test, and the residual flow observed on the flow test. And so these are, 2 points on the water supply graph paper. And so you would draw a trend line and extrapolate this out. And a lot of times they will give an approximation of that pressure at 20 psi, since that is the code required minimum that you're allowed to run out the municipal water supply capacity to. You don't. That's a code driven factor. When you are taking a look at the difference between these 2 points, I like to take a look at the point of greatest interest, which is the system demand point with hose. So the most common application of a fire pump is a pressure deficit. You have the flow available, but not the available pressure at the point of interest, aka the system fire protection demand point. And so what you would want to do is to draw a vertical line and find the intersection of the water supply capacity and the, fire protection system demand. And so you would get if you take the pressure required at the fire protection system demand and the pressure available at the water supply capacity at the flow intended for the fire protection water supply, what you would have as a delta is the pressure required to be accommodated by the fire pump. I'll throw another shameless plug for MyFire in here and drop a link to his calculator for water supply analysis so you can get an idea of what calculating the delta between what your water supply can provide and what your fire protection system demands, and so you can get an idea of how to navigate the selection of a fire pump. After you determine the pressure you need and the flow you need to select a fire pump with these qualities. So a fire pump is comprised of a number of different parts and pieces. Some are required when you have different drives of fire pump. So an electric fire pump's components are not the same as a diesel fire pump's components. Maybe that is blatantly obvious and a little bit pandering, but I just wanted to talk about some of the different parts and pieces of a fire pump system. Some of the parts and pieces that are crucial to fire pump design are butterfly valves or control valves, not specifically butterfly valves. So different points in the system where you can isolate the water in order to do maintenance or facilitate different functions of the fire pump. So suction and discharge control valves, and also extra control valves for the bypass. If you have a bypass, a fire pump bypass is a piece of piping that basically supersedes the fire pump. And in the case that the fire pump is inoperable, you can still have water supply capacity from the city in order to supply a portion of your system. The only reason why you would need a fire pump bypass is if there is a significant source of your significant portion of your system that can be operated by the city water supply. So if you have a fire protection water storage tank, you don't need a fire pump bypass because there is not a sufficient supply from the fire protection water storage tank in order to operate the fire sprinkler system in most cases, I would say. I'm sure there are some obscure cases that I'm not thinking of, but generally this is the case. And so there are also check valves in the discharge portion of the fire pump, also in the fire pump bypass. What a check valve does is to limit the flow of water, a check valve in the fire department connection as well. Another piece of equipment germane to fire pumps is the test header, a way to test the fire pump. You want to test the fire pump when you initially install the fire pump and at regular intervals where required by NFPA 20 and NFPA 25. So another piece of component architecture of a fire pump is we talked about the controller, but also we could talk about the jockey pump. The jockey pump, also known as a pressure maintenance pump, is a smaller pump in order to regulate the pressure differential in the system so that the fire pump does not activate. So the way that a fire pump activates is it has a sensing line hooked up to the fire pump controller, and it gets a reading from the discharge side of the fire pump, and there's a set pressure and that the fire pump controller has that's programmed into the controller, which the fire pump controller knows that if the pressure gets to this set point, then it operates. And so the jockey maintenance pump, or the maintenance pump, or pressure maintenance pump, or jockey pump, knows it's basically a much lower capacity little fire pump that's just helps keep the pressure that fluctuates through regular leaks and pressure surges in the water system. It can change. The pressure can change, and so what the jockey pump does is it prevents the fire pump from kicking on, and instead the jockey pump will operate in order to limit the amount of times that the fire pump needs to turn on. So it'll save the bigger piece of equipment. So if we take a look at diesel fire pumps and the components that they have, they're a little bit more complicated than electric fire pumps. And so the most simple fire pump is probably the electric fire pump without the transfer switch and the generator backup. And the most complicated is probably the diesel fire pump. And so diesel fire pumps only come in horizontal split case. And we haven't talked about the different types of fire pump. There's a myriad of different types of fire pumps. Really, I see two most common, which are horizontal split case and vertical inline. There are other use cases for fire pumps and model types like vertical turbine or multi-port pumps, but I don't have much experience in these areas. Most commonly, I see horizontal split case if I have a space that is limited in programmatic architectural space and has a relatively low demand. I would look into a vertical inline pump as an option. And so some of the diesel components that are different from an electric driven fire pump are you need a fuel source, and you need to monitor the fuel source. And there can be different requirements for when you have this fuel source in the fire pump room. It can make your fire pump room of a greater hazard. Diesel fire pumps have exhaust and exhaust manifolds. You need to exhaust the engine exhaust from the diesel fire pump either through the roof or through the sidewall. Diesel fire pumps also have the capability to have pressure relief valve. This pressure relief valve is due to overchurn or overclocking the diesel fire pump. And in the event that this happens, it discharges to the exterior of the building or back into the fire protection water storage tank. That's all I got for this episode of the Solocast of Fire Code Tech. Don't forget, if you want to find out more, go to patreon.com/firecodetech. Also, I forgot to mention that the standard for installation of fire pumps is NFPA 20, and the code section in IBC is Chapter 9, Section 913. Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.